Hey folks, welcome to Advent of Code in F Sharp, day 20 already. Day 19, I'm sorry, uh, was hard, or it looked hard. We played around with some rotations yesterday, uh, and that's where it ended. It was two hard puzzles in a row because day 18 was also pretty tricky to solve. And I decided to have a weekend instead, or a non-programming weekend. So we'll get back to day 19 when we feel like it. But for now, let's take a look at today's puzzle. I took a quick peek before I started with my morning obligations, and it looks doable. It looks like a smaller puzzle again. So basically, trench map, we get an image enhancement program, or we have to enhance images. We get two things in our input. One is the algorithm, but it's just a vector or an indexed list, and we do something, or the rules of what an enhanced pixel looks like depends on its neighbors. So it's cellular automata all over again with a funny encoding or a different encoding for the rules. We just have to calculate a number based on the neighbors, or binary number, and that's the index we have to take a look at for the next pixel. So that sounds very doable, very comparable to stuff we already did. There's a fun caveat. It's an infinite grid, so the thing can enhance infinitely. So this is where the choice between array2ds, or like arrays, and hash maps is obvious, or no, not obvious, but it makes a lot of sense to look or use a data structure like a map, because now you can grow indefinitely. So yeah, let's get started. I am going to grab the example, because as always, let's start with parsing our input. This is the example. Let's grab our actual input as well, which is quite a lot bigger. Interesting. So the top row should be our algorithm, yes, and then we have a big-ish grid of 100 by probably 100. Yes, 100 by 100 pixels. And our job is to, what was it again? To enhance a couple of times. Yeah, we need to enhance, or we need to apply the enhancement algorithm twice. So that does not sound too hard. Let's try it out. Oh no, before we try it out, there was one thing I was not sure about, and that is how to convert binary to decimal. So let me quickly play with it. Is there a convert from base? How did you do this again? So convert to an integer, whatever. In base 2, can you do something like this? Close string from base int, yeah. Does this work with like leading zeros? That was the only part I was not sure about. 1, 2, 4, that looks correct, right? Let's take a power of 2 so we're sure. Is that a power of 2? This should be a power of 2, right? Yeah. 1, 2, 4, 8. Yeah, that looks correct. And that should stay the same if we prefix it with zeros. That is the only thing I was not sure about. Yeah, okay. We can get started. We know enough to blast through today's puzzle. In stark contrast to yesterday's puzzle, there is something about 3D geometrics that my brain just will not accept. 3D is like doable because we live in the 3D space, but no, my brain says no. But anyway, let's look at image enhancements today, right? Let's parse this. So we need to parse this thing into the algorithm and our grid. Algorithm is just, let's keep that as a list or an array. So algorithm is our input. Just the first line. Will we be parsing, or will we stay in the character world? Let's stay in the character world. Should we stay in the character world? Yeah, sure. We don't need types today. Or discriminated union types, at least. So if we look up something that's... in the algorithm, that's just an index, right? So our first one is a point. Or our second one is a point, sorry. First one is a point. Yeah, this will work just nicely. So this is our algorithm. Applying the algorithm just means calculating a binary number from the neighbors of a cell. Yeah, I see this happening. So let's continue on. What do we call our image? An input image. So let's call it image as well. Oh, that's caps going wrong. So these are all the remaining... Is it remaining? Or should we skip 2? Because there's a new line in there. Is this the start? No, that's not the start. Sorry? Oh yeah, okay. They messed up the input. They use the new lines, and that's not really something that is in the real input. So let me just fix that by making a horribly long string. My formatter will have no issues with that. Cool. So that should all still work. We still have an algorithm that looks correct-ish. Last character is a bang. Maybe. We don't know. Okay. So this should now be correct. Yeah, that's the things we need to parse into our grid. Yeah, let's iterate over the rows and the columns and build a map. We need the indices. We need the indices, right? We need the indices, so maybe I should... also the structure on those. So on row, column, we have col. Let's call it pixel instead. So we don't confuse ourselves in the heat of the moment. This is a flat list of key values where the key is a coordinate. The value is the pixel. So if we do a map, we now have a dictionary or a map mapping coordinates to values. And it appears to be correct, right? Yeah, then we have a bang, and then we have a point. Then we go to the next row. And there's all points except for the first one. Yeah, that looks correct. That wasn't too bad. Let's put it in a function. If my Visual Studio allows me to put stuff in a function at least. Okay, there we go. I've got my new laptop from work, but I still need to set it up, need to install everything. So that'll be something for the holidays. Parse some string into our output. There we go. And let's return the algorithm and the image itself as a tuple. So now we can call this on whatever, not just on the example. Visual Studio, don't you go crazy on me today. Cool. Every save takes 10 seconds. I don't know what's happening. It's not a string, it's a string array. I just noticed, but let's take a quick peek at what's happening. Nothing unexpected is happening, so never mind. Let's parse the example again. Are you going to hang on me every time I press save? Because that will be an interesting constraint. That still looks correct, right? Yeah. Let's see if we can parse the input. That's also always a good sanity check. No, we cannot. Interesting. Why is input empty? Okay, there we go. My REPL did not know about the new contents. Does it start with point, bang, bang, bang? Quick sanity check. Point, bang, 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 and a very long algorithm string. It does. So that is the algorithm and image parsed. Today I am not the bottleneck. Today my computer is the bottleneck. Let's see how much patience we can muster. I should stop hitting save. Okay, there we go. What's the next step? The next step is to go over everything we need to take a look at, so we can calculate the next or the enhanced version of an image. What do we need to take a look at? It's an infinite grid in theory, but probably we will not need to take a look at every cell in the infinite grid. So let's take a look here. What happens in the infinity thing? That's all dots, and a dot was dark pixels. How does that translate to binary? How do we convert to binary again? Oh, there we go. Dark is a 0, light is a 1. So all dark pixels means all zeros. So that means binary 0, index 0. So the first rule, that's what happens in a dark corner of our universe. And that stays dead. Okay, that makes sense. Otherwise we'll have like a mega explosion after the first enhance. So we don't need to take a look at every cell in our infinite universe. What do we need to take a look at? The cells we know stuff about? Sure. What else? Could it be if we take a look at the cell, something like this? Let's zoom in a bit. Is this something that might trigger? I think so. Yeah, I think so. So maybe let's take a look at the cells and one border around the grid we know. So not only the cells we know about, but also the neighbors of the cells. I think that should be enough, or at least for what we know now, looks like a good working thesis. Yeah, so same old, same old. We need a couple of building blocks. We need to figure out neighbors for a given coordinate. We've done this, I don't know, 5 times already this year, so that won't be much of a problem. And we need to write some kind of step function that applies the enhance, or an enhance function that applies a single step of the enhancement algorithm. So let's first do the neighbors thing. So neighbors in an image given location. And it's not just neighbors, it's actually 9 things. It's the thing itself we need to take into account as well, right? Yeah. 9 pixels from the input image need to be considered. Each pixel of the output image is determined by looking at a square of pixels centered on the corresponding input pixel. So let's call this no, let's just call this neighbors, but like with an asterisk, it includes the cell itself or the location. So these are neighbor locations. That was a bad move on my part. My auto formatter thought I was done. Don't press save unless you have like a compiling code base. Pro tip, otherwise you're in for a world of hurt. Cool. Neighbors. I like applying the same strategy every time, which is just declaring the deltas. So this is to the top left of me. Rows are the X component. Yeah, sure. This is right above me. This is top right of me. That was not what I was trying to do. This is what I'm trying to do. And then for on my same row and below me, on my same row, what changes? X is the row, so that's just same row. Same row, and this is next row. Before we press save, let's verify this now that we can read it. Yeah, that looks correct. So these are the offsets, and we just do a map with this offset on the given coordinate. Sure. And I see R and C and dx and dy. That is a bad idea. Let's call this dr or delta r, and dy becomes dc, delta for the column. And these are actually the neighboring locations. We don't need the image for that. That's correct. And now let's grab values out of the map. Do we need to do it? No, we can just write a single accessor pixel at given an image and a location. And it's an infinite grid, so whenever we access stuff that we don't know about, we can just assume it's part of the infinite space and it's a dark pixel, which was a dot. So let's try to look it up, the location in the image map. Try find, is it potential? Why is it not completing? There we go. This tries to find a given location in the map, and it returns an option, but we don't need an option, we need a value. We can say option default something, default value. Yeah, so if we have the option, it explodes the option, it takes the sum value, but if we have a null case, we can just provide a default value, which is a dark pixel. Maybe I'm going to make a type alias for our image, because we are going to be using that a lot. Yeah, so our image is actually a mapping coordinates to characters right now. So let's have a... Okay. I'm gonna do one more. Our algorithm is just a character array. There we go. So our parse returns the algorithm and an image. And now we can annotate our... Ooh, is this not correct? No. Type level, we need asterisks, not comma. Cool. This just takes coordinates. Pixel at takes an image. So let's annotate this with the type explicitly. 0 chance for error. There we go. I think we're mostly done actually. Let's take a look here. Say we have the algorithm and an image. Let's try taking one single step. My Visual Studio is still not having any of it, so I hope it doesn't bother the stream too much. How do we take a single enhancement step? We iterate over all the relevant coordinates, so everything in our image and its neighbors, because we can have like fringe effects or effects on the edge of our universe where we need to do stuff. So let's first gather all the coordinates we might want to do some work on. Interesting locations is what? Everything we have in our image. Maybe we can do an optimization and keep our image like very small, only containing the lighted up pixels, but that's an optimization for later. I don't think it'll hurt us that much for part 1 at least. So keys. So these are all the locations our map or our image knows about. And this is a finite list, so we can work with this. And now let's map each of these to their neighbors, so the full 9x9 grid. And let's put everything in a set again to get rid of duplicates. So to get all the neighbors in a single list, we can use collect instead of a map. It's just the same, but it flattens lists we get as a result. So this is a location. We can do neighbors of this location. So this is like all the neighbors for everything we know about in a single sequence, and then we can just put everything in a set. I think this is the work list, or the list of interesting locations for a given step in the enhancement algorithm. Let's see what that looks like. It's already taking peeks to the left of the known world into the darkness. But that's correct, that's what we want. What do we need to do now? We need to apply the rules. Sure. Yes, we need to transform each of these locations to the next state. Yeah, and to do that, we need to again look for the neighbors of that location, convert it to like a binary number, and then look up that number in the, what was it called again? The algorithm array. And then we have like location in its next state. We just update our map with those next states, and we are done. Yeah, let's go. So interesting locations. I'm not piping everything in one huge pipe. I just want some like explaining variables in here once in a while. So we will be mapping. We have to drop out of, or we don't have to, but let's drop out of the set world. That was just to get rid of duplicates. I think you can even do like sequence.distinct as well. So we never enter the set world in our pipes at least. That still works, so what do we need to do? For every location, find all 9 neighbors. But I'm gonna keep track of the location itself, so we can have that as a key at the end of our pipeline to update the map with. So let's keep track of the location, but also grab the neighbors, which includes that location, but let's not make our lives harder. Let's just keep both. So this is now location with all its neighbors, or all its neighbors' locations at least. And then we need to find the pixels at those locations. So location and neighbors. Still, let's keep track of the location and map the neighbors to location add, pixel add. And provide the image itself. So this now maps every neighbor to the pixel at that neighbor location. I think that should work. It does, but it looks awfully empty. Is it because we're at the fringe? Let's see. I want to see some values in there as well. Okay, we have values in there. Cool. Next step is to convert this to a binary number, but actually to a decimal index. Do we need 2 steps for that? Yeah, let's do that in 2 steps. So we have a list of characters, which is what we have right here. I'm going to grab one of those to play around with. So characters is literally this thing. Let's play around with it a bit. How do we convert this to a binary? That's just a map. If we have a dot, that means it is a darkness, so that's a 0. If we have a bang, that is a 1 because it's lit, and otherwise we just crash. We don't care about edge cases here. That's a character, so I think you can do $C to print it out. Oh, sweet. 0000. Uno, that looks correct. Let's put a bit more ones in there. Yeah, that looks correct. And let's make that a string instead of a list of integers. Just because we can and because we know what's coming. So this maps everything to a list of strings, and then we can concatenate those strings into a single string with a empty space delimiter. So now we have a single string representing the number in binary, and that's enough for this little helper. Santa's little helper function to binary. There we go. I'm comfortable with it as it is, but I'm gonna write a single test as documentation here. So let's make a small binary number. Sure, let's make a small binary number, and that should evaluate to 0, 1, 0. Yeah, that worked. Cool. So that is converting our neighbor values to a binary. Next is to convert that to a decimal. So that is encoded as a string. And we can just do system.convert as we did in the beginning of the stream, binary in base 2. Convert to a long or an 9 bits is definitely enough for an int 32 kind of thing. So these two steps convert light values to binary and convert binary to decimal, which is exactly what we need. Let's take a look at where we were in the big scheme of things. Whoa. I pressed some button. I don't know what button. Okay, there we go. It was actually a cool view for live coding. What does full screen mean? Going off on a tangent here, I'm sorry. Shift Alt Enter. Cool. Let's proceed using a full screen view. You learn something every day. Anyway, getting sidetracked here. So now we have our interesting locations. And we end up with a list of locations and the pixels. So let's proceed here. No, let's not proceed. Yeah, let's proceed here. So this is the pixel. Let's do some more. So every pixel list, let's convert that to binary. And let's convert that to decimal. Does that work? No, because I'm doing it wrong. Oh, come on. Okay, roll back. I'm making it harder than needs to be. Roll back to a stable state. Okay, this is a stable state. Yeah, that was too hard for me, so let's just do this. Yep. Let's take smaller steps here. So pixels, and then we can convert that to a binary and convert that to a decimal. Yeah, so now we have location and the index. So let's now apply the algorithm. Which is just algorithm at the binary index. So algorithm is, I think we have a type for that, algorithm. Yes, we do. So we can apply our algorithm. And we pipe in the binary value. Cool. I'm missing some parentheses here. I think that's it. Let's see what happens. Nothing, because we have sequences. Let's evaluate those. Yeah, there we go. We have something here. So this should be a location and the new state for that location. Yeah, now all that remains is to update our image. So for every location we have here, we have the new value for the pixel. So that should be like folding over this list and just updating our map, right? I think so. So let's write a helper function folder or apply update. And we start out with the initial image. If I can type at least, there we go. And apply update is a little helper function that takes a location and a pixel thing, and it takes an image and it should return an image. This should line up. It's not lining up. Wait. So the fold function takes a folder function, which is our apply update, and an initial state, which is our image. Image is the map thing, right? Image is the map thing. And that apply update function should take two arguments, the state and an element. Oh, that's what I'm doing wrong here. Order of arguments, mix up. There we go. To apply a single update to an image means to update the map at location with the new pixel value. And that adds new stuff or updates existing keys. So that works exactly as we want it to. Should we do that micro optimization here and get rid of all the elements in the map that are darkness? Now, let's do that when we run against performance issues. So this is a single step of the algorithm. That wasn't too bad. No, that wasn't too bad. This is part of the algorithm. These are all just functions. Yep. Cool. Let's take that logic and put it in a helper function called enhance. Given an algorithm and an image. So that does what we have been doing here. It finds the interesting location in image. Yes. It loops over interesting locations and does everything we do. Yes, yes. We are using algorithm, correct. We are using image, correct. I think that's it. It's funny, if I solve advent of code puzzles, the decision on when to write a test for something and when to just forge on ahead, I have no idea when I make, or what heuristics I use. I have like this one teeny tiny unit test for encoding to binary, and I cannot explain why I did that. But anyway, let's enhance our image. Is the order correct? Yeah. So we can call our enhance function with the algorithm, and that should apply one step of the image enhancement process. And I'm gonna write a helper function enhance prime, which is just enhance with partial application of the algorithm, so we don't have to keep typing it again. And now we can just say enhance prime, and we can do it as many times as we want. Or for example, 2 times, which is what part 1 asks us to do. So this is the twice enhanced image of the example. And now they ask us to count the number of lit pixels. Doesn't sound too bad. Let's try that. So you can filter a map, and the filter predicate takes the key and a value and returns a bool. So we can just say v equals lit, and we are still in character world, so that's it. And we can just count the number of values in our filtered map. That gives us 35, which is correct. So let's run this on our input. Let's run this thing on our input. That's already a whole lot slower, so we might want to do that optimization. But first, let's see if this is correct. No, it is not. Surprising. Oh, I hate it when this happens. What is it? It is too high. I hate it when this happens. First, let's double check our code that we're not, like using a variable somewhere where we need to use an argument. So I'm gonna double check that by just moving my input data down here. So the code above has no way to read that. That is not a problem. That's a shame. 99% of the time when I have bugs like this, it's because I have a reference to like one of the global variables. But that's not the case. That's a shame. Okay, I'm gonna do a quick scan of my code to see if we can spot an obvious problem. Or no, actually, I don't think there's a bug in the logic because it works for the example. Maybe we can do one more thing. So this was too high. Let's remember the too high value. Hey chat, have you finished day 20? I'm struggling on part 1, or not really struggling. I'm hitting a surprise. Worked for the example, does not work for input. So now I'm going to go into troubleshoot mode a bit. How will I troubleshoot this? Will it help to print out the grid again? It's a quick thing to do, so yeah, let's print out the example grid, see if we can spot a problem. Yeah, let's do that. So let's write a print function that prints out the image itself. So this is like a map right now. It will help if we have a string again. So let's write a for comprehension. Sure, let's write a for comprehension. No, it's a image is an image. And that is a lookup table or a map. Let's first figure out the dimensions. Let's grab the keys. And let's get the max by, or let's map to the row. That's the first component of our coordinates. And let's grab the max. So that should be the max row. Max column is almost the same, except we max the second component of our locations. Let's see if we're already writing bugs here. Let's do a quick, check. And let's not return it or specify return type so we can grow it organically. We print image, that's what we need. Is it a 4x4 example or a 5x5? 1, 2, 3, 4, 5. Yeah, okay, cool. So it's also a square for our input, so it doesn't really, you don't really have to get both dimensions. Let's call it dimension instead. Okay, cool. Now we can loop over coordinates. Yeah, let's do that. Row in 0 until dimension is 4. So from 0 to 4 is the 5, 1. Yeah, that's correct. Let's do a nested for comprehension with nested lists as well. So 4 column in 0 dimension. Do something else. Let's look up pixel at row column. Why is there so much green? Go away. Okay. What does pixel at take again? The full image and a coordinate. Cool. For a row, let's concatenate everything we find with in just a new line without a separator. So then we need to make our character strings. There we go. And in the end, let's concatenate our rows with a new line. And I think that prints our entire thing to a single string. And auto formatting kicks in. I don't think I like the auto formatting, but it is what it is. Never fight your tools. Does this work? It prints something, is that correct? It's the base image, so it should be this thing, right? That looks correct. Do we know more? We got 1 tick. We got 2 ticks, so let's print our 2 ticked thing. Does that look correct? That looks nothing like... Wait a second, that looks nothing like it should, right? What is happening? 2 enhancements. This is the base image. Our base image is... Wait, that's not the same image. Am I looking at the wrong... Am I looking at the wrong example here? Actually, that is the same. Yeah, that is the same image. I'm confused. Or maybe this is just the bug we're looking for and we got lucky with the example. Yeah, this looks nothing like... Interesting. Let's print this out nicer. There we go. Did we make a row column bug? I kind of recognize parts of it. And then I don't. It looks like that outer... Is that exactly the problem? It looks like this outer thing, the outer border, we skip it. So this top row, it's not here. And that left first column, it's not there either. How can I get a correct answer? Did I ever use slice map? No, I have never heard of a slice map thing. Is that something we need to take a look at today? Map-like data structure with slicing. I know of slicing, I know of maps, but no, I have never used both concepts at the same time. Might be something interesting to take a look at later. But first I want to figure out why I'm dropping an entire column and row. Interesting locations. That's where we try to prevent this issue, because we look at the keys we know about and then the neighbors of those keys. But it looks like something's not really happening here. What is not happening? And how can we end up with 35? So we do 2. Oh, wait. What am I printing out here? A single enhance. Okay, yeah, makes sense. So this is the original image. This is a single enhance. And we are seeing that we are dropping off. That cannot be correct. We get 35. Maybe my printing has bug. What is this called? Enhanced. Let's grab that thing. Let's see if we can count 35 lights pixels. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 24, 27. So our printing is messing up. Oh yeah, no. I thought our world grows. Maybe we're forgetting to scale our dimensions as well, but we calculate our dimensions every time. Is it the XY thing? It's the XY thing, probably. Because maybe with the infinite thing, it's not true that these stay the same. Kind of makes sense now that I think about it. That was a stupid assumption. Or not stupid, but that was an incorrect assumption. Did this change something? It changed something, but that doesn't look correct either, right? It looks like it's doing the off by... No, it's the off by 2 now already. It's getting worse. Oh, no. What is happening? Okay, back to first principles. We are parsing the example. This is the example. Let's print the example yet again. The example is called image after we parse it. Yeah, maybe let's send this function back to Rebel. Okay, so example. So far, so good. Yeah. A single enhance. Let's do that the other way around. So enhance a single time, and then to string that, it's enhance prime. Am I messing up something with enhance prime? No, because the algorithm never changes in between rounds. No, that's true. Only the image changes. This is a single enhancement, so we can have a bug in our enhancement, or we can have a bug in our printing logic. And we know the bug is in a printing logic. We've been here before, right? Let's count our light pixels again. So image, enhance, count me some pixels that are lit. 24. That was correct, right? 4, 7, 11, 15, 18, 21, 23, probably 24, and I'm missing 4, 5, 6, 7, 8, 9, 10, 11, 16, 17, 18, 19, 20, 21, 22, 23, 24. So this appears to be correct. It's the printing that contains a bug. And it looks like for some reason I am missing the entire top row and the entire left column. No, that's not true. Yeah, that's true. How? Oh, of course. God dang it. The printing was easy, but it doesn't start at 0. We have negative coordinates in our map. Silly. You can probably do this way more elegant, but my brain is reaching a point where I kind of need to take a quick rest, so I'm just gonna do the stupid or the straightforward thing. Whoa. Formatting did a bit too much, so okay. Min row, min col. That will look much more in line of our expectations. Yes. Okay. So I write this little helper to print to debug my code, and there's a bug in the printing code. I love it when that happens. I love it when that happens. Cool. That debugged our printing. So let's take a look at the twice enhanced image. Back of the napkin. That looks actually pretty okay, right? That looks like it's correct. Uh-oh. Okay, cool. What can be our bug? Let's grab our input again to make sure I didn't do any copy-paste errors. Let's plug that in again. Uh, 5361, that's exactly what we did a couple of minutes ago, right? Yeah, that's what we did, and that is not correct. Shoot, it works on the example. We can even visually verify that it works. I'm just gonna do one last check before I dive into debugging something where we know nothing about or where we have to manually verify everything. Yeah, that looks correct. Okay, so let's parse our input and cross-verify our parsed stuff with the actual input to make sure we're doing the parsing correctly. Let's actually just print our input image. Oh dear. Yeah, let's just take a look at the first row, the last row, stuff like that. So we have something like this. Can I put these next to each other? Does that work? Oh, actually, this is good enough. So that's the algorithm. This is the start of our grid. I see correct stuff happening up until the last line. Yeah. And the first column also looks correct. This looks correct. Bottom row. Yeah. I see no problems here. Let's take a look at the algorithm. Let's print it out nice as well. So let's make everything a string and let's concatenate everything back into a single string. And let's cross-reference that with what we have. Oh, I really hope it's a parsing issue and not a bug in the logic, but actually this looks cool. Let's look at the final few characters. That looks correct as well. Oh no. So bug is not in the parsing. We are not using some state from the example when we're calculating with the input, right? Yeah. Mm-hmm. Okay, let's take a look at our main loop here. Enhance algorithm. Take a look at interesting locations. Maybe there's a bug here, or not a bug, but a wrong assumption. Does it make sense that we only take a look at everything we know about, everything in our universe or in our image, and the borders? I think so. Because if you look at how rules are applied, we only take a look at the 8 neighbors and the cell itself. So we never look ahead more than distance 1. So this has to be correct. Take all the locations we know about, grab all their neighbors and the node itself or the location itself, put everything in a single set, and these are the points to work at, the points to evaluate to see if they need to change. Yeah, makes sense. Still makes sense in my head. Then for every interesting location, grab their neighbors, including the location itself. That is true, right? I am including the location itself. Yeah. Then translate those neighbors into, or those locations into the actual pixel values at that location. And if we don't know a location, that's because we're outside of the known universe, so that should default to black. Correct. Translating to binary, translating to decimal, applying the algorithm, which is just indexing in that array. Yes. And then apply updates. Is this where things can go wrong? Is this where things can go wrong? We should end up with a single... There can be no duplicates in this lock thing, right? There shouldn't be. You just pipe it along, pipe it along, pipe it along. Yeah, we just pipe it along. Where is the bug? I think I'm getting a work call. It's my holiday. Yeah, I'm not gonna answer. Let's reread what is expected of us. The small details are really starting to come through. After enhancing the original image twice, 35 pixels are lit. Start with the original input image and apply the image enhancement algorithm twice, being careful to count for infinite size. How many pixels are lit? So they're asking the same thing as the example. There's no like, gotcha. The thing that makes it hard to debug or to get started debugging for me is the image algorithm thing. When I do like cellular automata, game of life kind of things, you mostly have these rules like 7 neighbors that are alive, next state is this. But it's the same thing, but it's it's pretty tricky to troubleshoot. We've kind of verified the binary encoding, right? Can there be... Nah, there can't be any bugs in there. Why is it working for the example, not for the input? What's the difference? It should be a, what was it? A 512-bit or an array of length 512, something like that. The image enhancement algorithm is exactly 512 long. Enough to match every possible 9-bit binary number. I'm just gonna shoot blanks until I get an idea. So we have our algorithm somewhere down here. There we go. Let's take a look at how long it is. Should be 512. It is 512. Let's do a 1, 2, 3, 4, 5, 6, 7, 8, 9-bit. That should be 512. 511. Yeah. Ooh. Yeah, no, that makes sense. So grabbing the 511th element in our algorithm should be the final thing, which is a dot. Let's quickly verify it is a dot. Let's see if we can go out of bounds. We expect it to crash. Yes, it does. This should be a bang. Yeah, everything seems to work. God. Do we really have to do a step-by-step debugging? I fear so. I'm afraid so. What are likely suspects? No, we are way past likely suspect territory. I have no idea where we go wrong. Our parsed input looks correct. Let's assume that is the case. So the only thing we do is call enhance twice. Let's start digging into here. Or no, we can do one more thing. We can print out the different steps to see if we notice anything super strange. So we are printing out the image, which was the correct image. Let's enhance once. That was a slow process. Yeah, it does something. That's all we can say. It even grows by 2. It should be growing by 2. I think so. Let's verify that. We have something to grab. Dimensions, right? Somewhere in our printer. Where is our printer? Where is our printer? Oh, we minimized it. That's why I was freaking out. Oh yeah, we just need the maximum column, maximum row. Let's verify that quickly. Totally messing around here. This is some crazy stuff, but I'm just trying to troubleshoot whether or not the thing grows in a expected growth size. Like, is it growing by 2? Oh yeah, we do need the minimum. I'm just gonna print out everything. We'll start playing with the image. So with every iteration of the image to verify whether or not this grows as expected. I'm not sure it should always expand. That depends on the rules, of course, but I really don't feel like troubleshooting a 100 by 100 grid. That's I'm delaying that as long as I can. So our initial image is a 100 by 100 kind of deal. And then it grows by 2. Sure, that's possible. Did my REPL just crash on me? No, okay. Okay, everything is according to expectations. That's a shame. The things I'm contemplating, like really slowly in my mind, are: should I debug this thing? Should I start printing out things? None of those options sound fun. And it's my holiday. I just convinced myself to take a short break. I don't feel like diving into debugging stuff during my holiday. I'll do that in a couple of hours once I played some video games, read some books, stuff like that. Really a shame. I thought today was going to be easy peasy. It's actually doable. We probably have a silly bug somewhere, or incorrect input stuff. I'm still betting on incorrect input stuff, although we verified. Anyway, I did not get another start today. Bit of a shame, but it's a fun puzzle. Really curious where my bug is, but we'll figure it out later. Thanks for watching, and I'll see you soon on Advent of Code in F#. Bye bye.